Today we will continue our overview of Python. Just a quick recap now and a chance to show you the slides that we didn't see last time. So last time we started this basic overview. Again, this is an overview of selected topics in Python programming and especially of selected libraries. For instance, why we mentioned the last time at the very end the how to handle missing values, because that's a very frequent task in data science. That's it. If you do something else with Python, probably you don't never have to care about missing values. Okay, so we are cherry picking basically what will be useful for us. Okay, that's the reasoning behind what to include and what not. Okay, so why Python? I already said it's basically the de facto standard together with R probably to do the data science. We didn't talk about the shell. It's a very quick thing to quickly prototype things, so you don't really use the shell when you are developing a script or let alone a full-fledged Python program. We have seen that variables have no type. Okay, there is no need to specify the type. We have seen conditional execution, various forms of loop. We introduced some data types like the lists. Okay, the tuple, which is a sort of list but immutable. Dictionaries that we can see that we have seen are a bit more structured data type. In Python, there is no array, strictly speaking, if you know arrays from other programming languages, but there will be something in a library that we will see today, which is called NumPy. And then we started also mentioning pandas, and today we will start from there, basically. There are many tools to program in Python. Today I will use the Google Colab, which is basically a specific version of what is called Jupyter here, or it is commonly referred to as Notebook. Okay, Jupyter Notebook. But whatever editor you already used to is fine. Some colleagues of you already wrote an email to me, I think, about how to set up VS Code. Okay, if you are comfortable with VS Code, fine, that's use VS Code. And specifically in pandas, we started seeing one of the two main data types that pandas give us, which is the series. We called it a one-dimensional data series, so a one-dimensional data type that is composed by an index and the actual values. Okay, so we did some of the examples that we have seen in the Colab should be the same that you have on the slides. Okay, so we created a list of planets, then we manipulated the index and stuff like that. We can create series with lists, we can create series with array dictionaries, and we have seen why to move from Python built-in data types to pandas data types. Okay, we are starting seeing this. They are more powerful. We can do the operator spread, the so-called operator spreading. So apply a mathematical operator to all the elements piecewise, to all the elements of the data series. That is something that we can't do with a list. Okay, we have seen that we have a very convenient way to filter data. Okay, with pandas, something again that we can't as easily do with lists, tuples, or dictionaries. Okay. And we quickly checked how to deal with missing data, especially with some, let's say, counterintuitive example. Okay, like sum in two series, which we will maybe expect a union of the two series. Instead, something weird happened, and we did check this behavior in the last lesson. So basically, this is was just an excuse to do both a quick recap and also to show you that whatever we see in the Colab and whatever we say in the Colab is also in the slides if you wanna static reference. So now we continue. Another way, okay, another motivation, another aspect to make us want to use pandas instead of standard Python data types is doing some basic descriptive statistics. So for instance, if I have a data series, or we will see even a data frame, let's recover our credit data series. So here we have the two series that we want to concatenate. We need to import pandas, which is this statement. Then we try to sum up, something weird happened. We do this, now we have, okay, our data series as we imagined it to be, as we expected it to be. We can have some quick descriptive statistic, okay? We can have, with the method describe on the panda series object, okay? We can have a quick summary. So how many unique values there are, the mean of these values, the standard deviation, minimum value, percentiles, maximum values, okay? And the nice thing is that this describe method is quite, let's say, smart. If we have different data types, if we didn't have numbers, for instance, but we had strings, so we have categorical variables, so variables that only can take a finite and discrete number of labels, the statistics will change. Okay, it doesn't. Maybe instead of the mean, for instance, we should have we could have the mode. Okay, the most frequent element, stuff like that. So it is quite smart, and it is very useful to get a quick overview about the data that we have. We will see that this also works with data frames. So in a case of a data frame that we anticipated is actually a table, you will have one statistic for each of the columns, okay, for each of the attributes that describe your data samples. And then we can also have quick operations on a data series, like summing all the elements, okay? 75 is the sum of all of these, like finding the minimum element, finding the index of the element with the maximum value, okay? Mean and max find the minimum and maximum values. Argmin and argmax find the index associated with the maximum and minimum values. Okay, these are frequent operations you may want to do. So here the maximum value, it is set to be at index 3, 0, 1, 2, 3. Okay. Instead, the minimum value is 7. So again, another reason to use pandas data types over Python standard ones. And now on to the, let's say, the most interesting stuff and the most frequent stuff, a data frame. A data frame, quickly, is nothing more than a collection of data series. Okay, so imagine to replicate the data structure that we have already seen multiple times. Okay, so here, for instance, I'm creating a data frame with two, how can we call it? Features, attributes, columns, okay? Call them whatever you want, whatever gives you a better intuition of what they are. As we said, we can easily interpret a data set, okay, that has 2 dimensions as every row is a sample of our data, okay? And every column is a feature that describes that data. That's the easiest way. I'm not saying that all of the datasets are made this way, okay? But this is the most intuitive way to think about data. And a data frame is exactly that. So we are creating a table, a dataset with 2 features, so 2 column names, if you think about Excel or an SQL table, whatever you are familiar with. Name and surname. These are the variables, and their admissible values are this one, or at least the values that we know. So we have a dataset with 2 features, and we are specifying the values of the features. Okay, so how many rows, how many data samples, data points will have this dataset? 3. We are specifying 3 values for each, so we will have 3 rows. In fact, this is the representation of our dataset. We have an index. We specified explicitly the index to be ABC. If we didn't tell anything, the index will be 0, 1, 2. Okay, that's the default index, but we already seen with series that we can manipulate the index as we wish. So we have 3 rows of data, 3 data samples, and 2 attributes, features, whatever you want to call them, name and surname. Okay. This is the description of the index. Okay. These are the columns. If we print the df, we get the whole df data frame. If we print the columns, we get the list of the columns. It is not actually a list, so if we want a proper list, we need to convert the data type to a list. This is something similar to what we see in the dictionaries. Now it's a proper list, okay? Sorry, let me do one thing if I can manage to. I wanted to do another thing. Sorry. Open this in another way. Well, never mind. So here. Then if we print the index, we get an overview of the index. Okay, so it starts from 0, it stops at 3, excluded. Usually the stop side is excluded with step 1. Why this weird description? Because that's a specific Python object. And then we also have this attribute. You can see that these are not methods. You don't have any parentheses, okay? So these are not methods. These are properties of the object. You also have a property which is called shape that quickly gives you the dimensions of the data frame. This is a table that has 3 rows and 2 columns, basically. Okay. So again, to have a quick overview of the kind of data set you have. So we can't easily create a data frame from 2 series in this way, like this. But we can do this. So if we want to create a data frame, we need to tell the first, we have to associate the data series to a column name, basically, okay? This doesn't work. This instead works. You have to associate one data series to a specific column name, because pandas need to know what is the attribute that that data series describes, okay? If you remember, in a data series, we didn't have a name for the attribute because there was only one attribute. So here, if we want to merge our previous data series in a way, so having for a number of people, let's say, a list of all the credits they accumulated, we need to do this. We need to associate a data series to a column name. And now we can actually have our data frame representation. Okay? In this case, we also filled the unknown values with 0. Why do we have unknown values? Simply because in either of the 2 data series, not all the people were there. So what can we do with a data frame? Whatever we want, basically. We can do selection. So this is very convenient because you can select columns in the data frame in the exact same way as you would select keys in a dictionary, basically, okay? Or in a very similar way with what we did with lists with the notational position. So we use the variable that stores the data frame, that refers to the data frame. We open the square brackets, and we put in the square brackets the feature that we want to access, so the name of the column, basically. Or more, The only thing that you should notice, so let's pick the first column, this one, okay? What we do expect. Type is a convenient function that tells you the data type that a given variable refers to. So for instance, here, the column is a Pandas series. Okay, fine, as we expected. And the column that we got is this. So keep in mind, is actually a data series, a series object, the one that we have seen the previous lesson. There is an index and there are values. We extracted the first column together with the index. There is always an index in Pandas, both with series and with data frames. If we want to select multiple columns at once, we can. Please notice that we need 2 square brackets. Okay? We can't simply say, okay, let's open the, let's say, positional notation, and then list the columns. This doesn't work, okay? Doesn't work because we need to specify a list of column names, where brackets are also used to denote lists. So we need yellow square brackets to have positional access, okay? And then the purple square brackets because we want to access a list of columns all together, not one. And this way it works, and we get both. Okay? And basically this time we have instead a data frame as a data type. Before we had a series because we only had one column. Now obviously we have a data frame because we have multiple columns. And the whole selection that we did that is actually equal to the full data frame. We can also access rows individually. There are many ways. It can be quite confusing, Pandas, in this respect for historical reasons, but the recommended way to access rows is by using the lock method. And this is very weird. I know it is not my fault. I am not one of the developers of neither Python nor Pandas. So why am I saying it is very weird? It is very weird because, as you can see here, okay, in this line, we have what seems a method, the f.lock, like locate, you can remember it as locate, but we don't have the normal parentheses, we have the square brackets. I know, it's confusing, I don't know what to do about it. It's the way it is. So, actually it's because lock is not a method, but again, it's another property like shape, like the one that we have seen before, index, columns. And then we need to access with the positional notation, this property. That's why. So please try to remember that lock seems a method, but it is not a method. You need to call the square brackets instead of the usual parentheses. So by saying df.lock ali, or whatever was in our index, we are asking Pandas to access one specific row in our data frame. Okay? So for instance, this is the row that we accessed. Again, it may be a bit confusing because this time we are seeing the columns not one next to each other, but one below each other. Again, I cannot tell, but that's the way that it works. So we selected this row. Okay. And in row Ali is an index. The column first has value 10, the column second has value not a number. Okay? Simply, they are displayed not as usual, but vertically. Okay? And obviously, if the index was a numerical index like 0, 1, 2, 3, we would use a number, not a string. Okay? Right. And we can also specify, as we did for the columns, we could specify multiple columns in one shot, we can specify multiple rows. And here the notation is the same that we use with the lists, for instance. So if I want all the rows, I can say select from the df, we don't use lock anymore, select in the df all the rows, because we start from 0 and we get to the last element. So this is a way to select all the rows. And in fact, we selected all the rows. If I did something like that, we selected only the first 2 rows. Why? Because as we have seen with range, 0 is included, 1 is included, 2 is excluded. Okay? I would say 100% of the time you have starting and stop ranges, stop is excluded in Python. So this is a very basic way to access columns or rows. And as we have seen with the series, in data frames you have the same support for operator spreadings, convenient methods, handling missing values. So usually there are very few exceptions, okay? Usually you can expect everything that works with a series to work with a data frame. Usually. There are very few exceptions. Obviously you need to read the documentation if you find some error, but usually everything that works with a data series works with a data frame. So it's very convenient. For instance, we filled our missing values, then we sum them, then we multiply them by 10, okay? So what else we can do with data frames that is more interesting to do with data frame than with series? Well, basically, pandas is a way to manipulate, as I said, datasets by taking data from somewhere. Many times the data, not in our course the data will always come from a text file because that's the easiest thing to do. But in most real cases, data will come from a database, for instance, okay? And again, not in most probably nowadays, but in many cases, the dataset will be a relational database, okay? How many, maybe I already asked this question, but how many of you are familiar with SQL and relational databases? Raise your hand. Okay, somebody. So if you are familiar with SQL, in Pandas, you can do basically the same operations you can do with SQL. You can do joins, you can filter, okay? I guess we won't see that, but I guess, if I remember well, that Pandas also has an API that actually uses the same names as SQL methods. So, if I'm not wrong, if I remember well. So, for instance, if we want to merge datasets, we have 2 datasets. Maybe they are about the same thing, let's say the same features, but different data samples. Okay, because I am periodically collecting data about a running machine, for instance, some industrial machine, some equipment. And so the data always has the same features, but I have different samples, okay? Or the other way around. I can have different datasets that describe the same samples, but with different features. So I want to merge the features all together, for instance. I can do both, basically. So let's assume that we have 2 data frames describing planets. This is one of the 2 use cases that I described. So I have a first data frame that describes the Earth, Mars, and Jupiter, the gravity that is in these planets. And another data frame that describes different planets, okay, potentially. Jupiter is in common, the other 2 not. And a new feature, the mean temperature on the planet, okay? So, this is our dataset. I didn't specify an index, so the index is a default numerical index. So, let's see what we can do. We can merge, which is a method, which datasets to merge, and what is the criteria for matching. This on parameter tells pandas how to merge the dataset. Let's see what happens. If we want to merge on planet, pandas, by default, will create a dataset that only contains, in a sense, the intersection of the two. The only two planets that appear in both data frames are Mars and Jupiter. So my resulting dataset has only Mars and Jupiter with the two features not aggregated, but concatenated, okay? This is the default behavior. I can change this behavior. So, if I merge on planet again, okay, but I specify how to do the merge, so how to consider the two data frames data, I can change the result. So if I specify inner, and this terminology should be familiar with those of you familiar with SQL, if I specify inner, that's basically the default. I get the same result as before. This is an intersection, so to say. Instead, if I specify outer, this is a union. I get all the planets, and I will simply get missing values when there are no values. So, in the first data set, Neptune was missing. So, I don't know the gravity on Neptune. So, I can expect Neptune to have missing value in gravity. In the same way, Earth was not in the second dataset, so I can expect the mean temperature of the Earth to be unknown, missing. Okay? I can also specify right and left, which means include all the values from the dataset on the left, include all the values from the dataset on the right. So if I say right, this is what I get, because I'm getting all these planets, Mars, Jupiter, Neptune. The Earth is not there, because it was in the left dataset. Okay? I would say that these two merge modes are a little less common. The same for the left. Okay. One nice thing that you may already have noticed, if we use function print to show the dataset, it appears this way. If we don't use function print, that is something that we can only do in this Colab or notebook or whatever, but not in a script, otherwise nothing happens, there is a nice feature that is not a feature of Python, but is a feature of this specific editor that actually shows you the table. That's quite useful. But again, this only works if you use one of these editors, not if you write a script with, I don't know, idle, VS Code, or whatever. Speaking of SQL, you can also do grouping. You can also aggregate data, okay? So with a merge operation, similar to SQL join, you can decide which feature to merge and how, okay? With a grouping, we can group together data. Let's see what this means. First of all, we see here a way to load the data from a file. This is the first time. So in Pandas, there are many very convenient methods to load the data from a huge number of different sources and file formats. You can even connect to a database, a proper relational database. You can even connect to a website, whatever. Here, read CSV, as the name suggests, reads data from a CSV file. CSV file, I don't know if you're familiar, but they are very simple files in which you have any new line is a different row in your dataset, and columns are divided by some separator that by default is the comma, as the name suggests. And usually the first line is the column headers, so the name of the columns. And then from line 2 onwards, you have all the data separated by comma. This is very, very common. This is the first time, so we can see how to load the data from a file. We can use this method, specify the path to a file, and if we want, specify if there is one of the column that should be used as the index. Otherwise, the index will be the default index, 0, 1, 2, whatever. One caveat. When we use Colab, again, we are executing the code on a server. So we need to put the file on that server, okay? So in Colab, you can go here in the folder icon and upload a file. So in this case, we are looking from your computer, from Drive, from whatever. So in this case, we are looking for the Planet CSV. Here there is a warning that says to you, watch out, when you shut down the Colab, the file is lost. So if you do some modification on the file, save it and download it before closing the Colab. Now we have this Planet CSV, okay? How does it look like? The Planet CSV. We will see it with pandas, but let's also check the file. For those of you that never seen a CSV file, it is completely okay. This way. I don't know if you can, yes. This is a CSV file, okay? It is not very human friendly, especially if you have lots of columns, but it's the I would say the most simple format you can have. As I said, usually, but it is not really necessary, but usually the first row is the column names. So name of the planet, diameter of the planet, mass of the planet, inclination of the planet, eccentricity, I don't know even what it is. And then all the subsequent rows are the different data samples, okay? So first data sample is Mercury, this diameter, this mass, this inclination, whatever. That's the easiest way. So if we read our dataset, hopefully everything goes well, okay. We read this dataset and we told the pandas to take the name as the index. And that's actually what we got. Okay, this is our dataset. If the dataset has many rows and many columns, when you print it, it is not printed in a whole, okay? But it is printed only, I don't know, the first few columns and the last few columns, the first few rows and the last few rows. It is something that you can configure, but by default, it is not displayed the whole dataset. This time it is displayed here. This is our whole dataset. So we, for instance, could ask the shape of the dataset. Planet df shape. Bum, 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 bum. 8 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, quick and easy. We can have descriptive statistics, whatever we said before. So now let's assume we want to specify another feature that wasn't available in the dataset. So whether the planet is mostly rocky or mostly a gas planet, okay? So we have this new list of types. Not by chance, there are how many types? 8, one for each planet. 1, 2, 3, 4, 5, 6, 7, 8, okay? And how can we add a column to a dataset? Easy, as we would add a new key value pair to a dictionary, same way. We take our data frame and we write as if we were accessing to a column that exists, even if it doesn't exist, because there is no column type here. But provided that we are assigning, okay, a list, a series could be, okay, to that new column, the column will be created on the fly. So that's very simple, to create new columns. Just create it on the fly and assign the value. Now, if we ask again for the shape, and if we check whether the new column is there, how can we check it? With our usual notation. We called the column type. Let's see what happens. So we have our old dataset, and our new dataset has an additional feature. And the new column is this one. Okay. Now what we want to do? Group planets by type. Grouping is a very common operation in data science, okay? I want to group purchase receipts by day. I want to group people by gender. I want to group, I don't know, faults by type, by severity, whatever you can think of. Grouping is extremely common. So there is a method, name borrowed by SQL, group by. So if we invoke method group by on our DF, our data frame, we need to specify what is the attribute, the feature upon which we want to group. Okay? This time we want to group by type. And what we get, here again, you must be a bit careful, is not a data frame. So group by is one of the few operations on a data frame that don't give you back either a data frame or a series. It is a new object, a group. Okay? Why I raise this warning? Simply because if you expect to be able to directly apply the usual operators like summing, like averaging, like describing descriptive statistics on the result of a group by, you can't. So we will have a bad surprise because you will have an error. Okay? So the group is this weird object. Underscore, if I print the group, okay, let's make it more clear. If I print the group, okay, type group, exactly the return type of method group by. Where is I lost it. I can't find it. Here. Okay, finally. You can see this weird print, okay? The group is this thing. Okay. We won't go into the technical detail, but we can agree that this is not helpful, okay? If I wanted to see my groups, this is not helpful. This is something for the IT department, not for the data science department. So That's to say, that's a weird object. If we want to actually see the groups, we need to iterate the resulting data type, which is this weird thing, this grouping thing. So usual for, we have an iterable object, we iterate. We call G every group, every element in this thing that I don't know whether it's a list, a dictionary, I don't really care. I only care that I can iterate the thing with a G, with a for. And then we can print for any group, we can print the index and the data frame corresponding to the index. Let's check. So G is the whole group. This is more similar to a data frame. It is not yet completely a data frame, but this is similar to a data set. We have all our data, but we only included gas planets. Jupiter, Saturn, Uranus, Neptune. Jupiter, Saturn, Uranus, Neptune. I can check here what the type of this index is. The index is gas, and that's a string. So what we see is that the index basically changes. It's like having two indexes. The outer index is gas rocky. The inner index is the one we had before. Jupiter, Saturn, Uranus, whatever. Okay? That's the weird thing about grouping. You introduce another index, which is the grouping. And then the next iteration, the data corresponding is this one, okay? Diameter, mass, inclination, eccentricity, semi-major axis, surface gravity, orbital, blah, 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 blah. This was the first group. The whole group, only the index, only the data frame. Second group, so these four loops have two iterations, one for each group, one for the rocky planets, one for the gas planets. The second iteration is this one. This is the whole group, index and data frame. Only index with its data type, only data with its data type. Okay, so this is, we have to deal with it. This is a specific structure that is the result of invoking a group by. It is not a data frame. The whole object type group is not a data frame. It is a different thing. But each group has the data frame only related to that group. So this is something, again, to keep in mind, because, I don't know, if you want to call describe on type group, I shouldn't be able to do it. Let's see what happens, if it happens what we imagine or not. This is the group. Let me check. Okay, just before the group, we should have some statistics. I don't see it. It's something weird, okay? I don't see the statistics. Instead, I can see the statistics if I ask for the statistics of each group. Okay, so at the very end, we have our types, and now we should have what is describe? I didn't print. Okay, we should see, I can scroll down, the statistics. Okay, these are the statistics that I expected, only for this subgroup. So now, we did grouping by basically separating objects, okay? We separated all the rocky planets from the gas planets. When we do grouping, oftentimes we also need to aggregate values. So we want to group data together and aggregate the data somehow. So to have, let's say, a less granular view of the data, okay? So let's say I have data about people. I can separate them by gender, and then maybe I want to aggregate data by showing only the mean age of males and the mean height of females. While I'm doing grouping, I can also aggregate data. So, for instance, if we take our group object, this is the group object, and we call method aggregate with a parameter that is a string, this corresponds to an actual, this can be an arbitrary string, okay? It can't be an arbitrary string. This should be one of a few specified strings. This is the operator to apply to do the aggregation. So what we do expect intuitively if we call this method, we expect to aggregate all the data in our groups by picking the maximum value. So what I get this time is a data frame. Aggregation turns back a group object into a data frame object. So this time we have a data frame, we are fine, everything is good. This time we don't have the whole list of planets. We don't have anymore. We are not looking at a single group, but we told the pandas, based on the grouping you created before, within each group, only pick the maximum values. In this case, for instance, this kind of aggregation doesn't make sense. Why? Basically because I'm mixing values. Maybe the maximum diameters is, I don't know, Saturn maybe, or Jupiter. And instead, the maximum, I don't know, mean temperature is Mars. I'm mixing data. Okay, this is just to show you. Perhaps a more meaningful aggregation this way could be doing the mean, okay? Or average, how is it called? I don't remember. Because we have some values that has been interpreted as a string. So this is not interpreted in scientific notation, but as a string. So we will need to convert them to have this mean to work. Okay, so I cannot show you now, otherwise I will need to convert it. But you can have many supported operators, okay? Mean, if it's applicable, you can sum values, you can have minimum values, you can have the mode. Let's try maybe with the mode if it works. I don't remember. If you want to check, no, mode is not a valid function, okay? So you can't aggregate with the mode. If you want to check, easy. Pandas aggregate modes, okay? As I said, when you start working with something, you check the documentation to understand what you can do. Here you have a description of everything you can do with the aggregate function, okay? You have examples so that you can expect the documentation to be quite well done, okay? So we can have multiple aggregations at one time, so we discover, okay? So if you want to deepen your knowledge, just go there. And you can have, basically you can have any information you wish on the specific function. Again, this is a very common operation on data frames. Grouping objects in some way and aggregating the data in some way. Obviously, that is meaningful to the problem at hand. Here, the examples are just examples. Here, for instance, the maximum doesn't have any sense. Okay,